this is going to be a really quick look at recursion, what it means, how to apply it, and we're going to see a couple of examples of when to use recursion and when not, and you can sort of decide from there. So what is recursion? Recursion, very simply put, is when something is defined in terms of itself. So if I said that mathematics has a lot of math involved, that's kind of a recursive definition because I'm using math to define mathematics. Also, a fun thing that you can actually do is you can go to your phone, go to Google, type in recursion, and it'll say, did you mean recursion? And if you click that, guess what? It takes you back to recursion, which takes you back to recursion, which takes you back to recursion. So as we can see from the Wikipedia article here, recursion is formally defined as when something occurs, when a thing is defined in terms of itself or its own type. It's not just a programming thing, but that's where I happen to use it since I'm a programmer. So let's actually think of a situation where we could use recursion. We're going to tackle the problem of factorials. What's a factorial? You might remember it from school as this sort of thing, a number followed by an exclamation point. And so what this expands to is 5 times 4 times 3 times 2 times 1. And we know that's equal to 120. The factorial starts at the number and then it decrements down all the way until you get to 1. And then once you're done with that, you get the result. So n factorial goes from n all the way down to 1, multiplicatively. So let's go ahead and look at two different approaches to tackle this factorial problem. We're going to do the iterative version, where we have a defined loop where we control the scenario that happens every single time we loop through the problem until a certain condition is met, and then we return a result. So we're going to go ahead, we're going to define a factorial function. This is just a definition, so we're not going to put the real number in here. Instead, we're going to create a generic input variable, n. Now inside here, we're going to define a couple of variables to help store the information we need in order to properly calculate the answer. We're going to define a result that's going to store the number that is final. And since we know that the last number in any factorial that is multiplied is 1, it's actually a safe bet to set it as 1, because any number times itself is just itself. What we're going to do to help our loop as well is we're going to define a multiplier. And we're also going to start that at 1. And so here's the basic strategy. We start at 1, we go up to n, and we keep multiplying every time. We keep multiplying the result by whatever the incremented multiplier is until we are bigger than n. So we're going to write a while loop for that. So while the multiplier is less than or equal to n, we're going to do the following. We're going to take that result number and we're going to say, hey, so you're going to have a new value. Your new value is going to be result times multiplier. And then after that, we're going to increment the multiplier by 1. This little bit of code on line 7 is just really fancy JavaScript that basically means multiplier plus 1. Once multiplier is finally bigger than n, we want to stop multiplying. Because as you can see, we don't go to 0 and we don't go to -6 in the example of the 5 factorial. So instead what we're going to do is we're going to return result. For us to see the result, we'll need to console log this, so that way it appears down in the terminal down below. So we're going to do factorial. We're going to give it a real input now that we have an actual definition. We're going to save this and we're going to run the function and see what we get for 5. And we get 120, as expected. All right, so now let's do this recursively. So as you might remember, recursive definitions mean that you have to refer to yourself in order for something to be recursive. Recursive problem solving in programming is when a function calls itself within its own definition to repeat the code with the goal to reduce a problem to be simple enough. It might sound like a lot, so let's actually take a look at this in action. Here we're going to start again with another definition of factorial. We're going to have the same generic input n for our function definition. Now, what we're going to do is we're going to test to see if the number we're looking for is 1. And the reason we're doing this is we're going to decrement instead of increment. like we did in the iterative solution. So we want to see when we reach 1. And you'll see why in just a second. So if n is equal to 1, then at that point, we return 1. It's that simple. Now, if it's not, what we want to do instead is we want to return n times factorial of n minus 1. And here's where the recursion actually occurs. We have a function call within its own definition. So at this point, this function is now recursive. So what would happen here is, let's just say we have 5, right? Is it equal to 1? Nope. Keep going. So we have 5 times whatever 5 factorial 4 is. So we have factorial 4. Is it 1? Nope. So we have 5 times factorial 4. So we have 4 times whatever factorial is here. So this would be 3. And then 3 times factorial 2, 2 times factorial 1. And when we get to 1, we finally get a terminal return. So here we have 1, and then we have 1 times 2, then 2 times 3, 3 times 4, 4 times 5. So if we've done everything correctly here, we should be able to run this and see the result in action. I forgot to log this. For us to see it down at the bottom, we need to actually log it, or else it's not going to do anything. All right, so let's go ahead and save it. And there you go, 120. And that is recursion in a nutshell.